So what is ionization energy? It's the energy that you need to remove electrons, okay? And so you're trying to remove electrons. So you're trying to remove electrons from an atom. So that is known as ionization energies. Or it's different ionization energies only. So basically, let's say for example, you've got an atom, lithium का atom का लेते हैं. Lithium has 3 electrons. ठीक है, just 3. अच्छा, so here's your lithium atom, और उसमें ना you've got a total of 3 electrons. So the lithium atom will have 3 ionization energies. First काम क्या करो? You remove the first electron, right? ठीक है, when you remove the first electron, it's going to turn into it's just going to lose 1 electron. That's it. It's going to turn into a lithium plus 1 ion. तो उसको उधर ही draw करते हैं, and ठीक है, that's your. ठीक है, now I'm going to draw the lithium ion. तो lithium ion जो होगा, that will not have this outer electron. ठीक है, the total charge of this thing will be, it's going to be plus 1. And similarly, you'll have 1 electron lost. Then what I'm going to do is I'm going to remove the second electron. That would be the second, one by one I'm removing electrons. Okay? So I'm removing the second electron. When I do that, so it's going to turn into a lithium ion again, but now the charge will be plus 2. So ये मैं second की equation डाल रहा हूँ, ठीक है? So the second electron is now lost. ठीक है? So we've gotten rid of the second electron. So that is gone. Or up. ठीक है? That's my second electron. That's gone. And now the charge on this entire thing is going to be plus 2. Okay, so that's my second ionization energy, and then there's going to be a third ionization energy where what will happen is okay, the very last electron would also be lost. Okay, so I'll end up removing all 3 of the electrons. So while I'm removing, अच्छा अब ये plus 2 हो चुका है, ठीक है? So this is plus 2 at the moment, and it has already lost this electron. Now we're trying to remove another of these electrons, okay? So the last electron is also gone. So this one is gone. And now the charge on this thing will be plus 3. And again, 1 electron is lost. So this is, bari, this is what's happening. You're removing electrons from lithium. So every atom has a set number of ionization energy. So this is the first ionization energy. Okay, I'm just going to refer to it as I dot E. Okay, that's my second ionization energy. And this over here is my third ionization energy. So if you had sodium will have 11 ionization energies because you can remove 11 electrons from sodium. Okay, so 3 electrons remove karne, it's going to turn plus 1. Then that plus 1, you remove the second electron, it will turn into plus 2. Then you remove the last electron, it will turn into plus 3. Okay, so it's a simple concept. That's what ionization energy is. Ye clear hai baat?
Ji sir.
Achha, so the first thing is you'd be asked to write equations for ionization energy. So we'll just practice it a little bit. So equations for writing ionization energies. So now the first one, let's do this. Let's say they ask you to write they ask you a question that what is the second ionization energy of calcium? ठीक है, if that is the question, so what will be the equation? So when you're talking about the second ionization energy, the first electron has already been removed. ठीक है, यानी first हो चुका है. When you're talking about the second, the first has already been removed. So if the first has already been removed, calcium is already 1 plus, and it's in gaseous state. Gaseous का मैं बाद में explain करता हूँ. And you're trying to remove the second electron. So when you remove the second electron, calcium will be turning into calcium 2 plus. ये state अभी बाद में discuss करते हैं, ठीक है, plus 1 electron. So that is the equation for the second ionization energy of calcium. ठीक है, is that clear? कि जब मैं second की बात कर रहा हूँ, the first has already been removed. If I'm talking about the third ionization energy, the first two electrons have already been removed. Now you're removing the third electron. ठीक है. इसी तरह if I talk about किसका करें? अच्छा, let's say I talk about the fourth ionization energy of chlorine. So what I'm trying to do is I'm trying to remove the fourth electron. The first three have already been removed. Okay, now I'm on the fourth one. I'm trying to remove the fourth one. So the first three are already gone. So chlorine is already +3. And now you're trying to remove the fourth electron. So when you remove the fourth electron, chlorine will become +4. And remember, we're doing this artificially in the lab. Chlorine usually electrons lose nahi karta. We're making it lose electrons. Okay, so 1 electron is lost. And this is the fourth electron. Okay. Let's say we have the third ionization energy of, let's say, aluminium. So what will be the equation for that? Third ionization energy of Al. अब इसकी जो equation होगी, that's going to be, you remember again, we're talking about the third. That means the first two electrons are already gone. Okay, you're trying to remove the third one. So you're trying to figure out what will happen if you remove, you've got Al +2, and you're trying to remove the third electron from it. ठीक है, so is this clear के equation लिखना आ गया कि states में बाद में बताता हूँ, but is this clear that the first thing that they're going to ask you is to write an equation for an ionization energy. ठीक है, बारी you're trying to remove electrons from an atom. If it's Cl is going to have 17 ionization energies. It's going to have a lot of ionization energies because you'll be removing 17 electrons in total. So अगर मैं Cl की ना 17th ionization energy की बात करूं, ठीक है, so if I talk about, let's say I talk about the 17th ionization energy of Cl. So what is the equation? It's going to be Cl में से ना the first 16 electrons are already gone. So Cl would be +16 because it has already lost 16 electrons. And now you're trying to remove the 17th electron. So it will become Cl with a charge of +17 when it has lost 17 electrons. ठीक है, तो हम एक Cl के atom को पकड़े lab में, and we're trying to get rid of all the electrons around it. So the 17th electron, we're removing the 17th electron. ठीक है, is this clear? ये clear है? Equation clear है सारों को?
जी sir.
अच्छा, plus इसमें why do I use the symbol gas? It's remember we're talking about isolated atoms. So lab में, if you have an isolated atom, you're trying to remove electrons from it. That isolated atom is not going to be bonded with anything, so it will most likely be in gaseous state. Yeah, the fact is solids or liquids, things are sticking together. They're kind of bonded to each other. So right now we're talking about an atom which is isolated. Okay, it's completely isolated. An isolated atom, when it's not bonded to anything, it will. So this atom over here can fly around anywhere because no one is stopping it. So it's going to be in gaseous state. Isolated atoms are always in gaseous state. Anything that's isolated, it's in gaseous state. Well, liquids or solid state, if to get into a liquid or solid state, you must be attracted or bonded to something, or you must be tightly packed. So that means the particles are attracting each other. So which is why we use the gaseous state as the symbol. Or symbol is important. You have to mention the symbol when you're asked to write the equation. Okay, so that's the first thing. As a second पे आ जाते हैं. So let's take the example of so let me draw the Cl atom. ठीक है. Sodium magnesium कर लेते हैं. So let's draw the magnesium atom. It's got 12 electrons. So it's got 12 electrons, it's got 12 protons in its nucleus. So there's a nucleus which has 12 protons. So there's a plus 12 charge on it, and all the electrons are attracted to this nucleus, 12 of them. So that's the first shell, that's the ये second हो गया, और ये आपका अच्छा ये आपका third हो गया. ठीक है. अच्छा, so you चलो ठीक है, काफी है. अच्छा, so you've got this model 2 electrons. अच्छा, 8 in the second shell. ठीक है, what this symbolizes is that the electrons are more energetic and they're further away from the nucleus. And this is 2 electrons in the third shell. So now if you look at the magnesium atom, and let's imagine you're trying to remove electrons from it. Okay, so I'm trying to get rid of this electron. Okay, I'm trying to pull this electron. So that's my first ionization energy. So can you explain okay, what are the factors that affect ionization energies? Like what factors are in place? Whether it's going to be difficult to remove this electron. I mean, remember the electron is part of the atom, and if I try to remove it, there's some amount of energy that would be required for it. So what are the factors that would influence it? What would make it difficult to remove electrons or easier to remove electrons?
Radius.
ठीक है, those factors affecting सबसे चलो ठीक है, radius है. लेकिन सबसे important factor क्या होगा? What's the most important factor?
Distance of the electron from the nucleus.
Okay, that's also a factor because it's going to be much harder to remove this electron, which is very close to the nucleus. Okay, so that is kind of radius. Okay, so radius, radius or distance, right? The further the electron is, the easier to remove, right? I mean, this outer electron, it's easier to remove because it's very far away from the nucleus, right? इसके अलावा, what are the other factors? Any other factor?
Sir,
Nuclear charge.
ठीक है, because ये influence करता है. ठीक है, if you had instead of 12 protons, if you had 20 protons, right? Like if it was a different element, then it would be a lot harder to get rid of this electron because it's going to be very strongly attracted to this nucleus, right? So magnesium के case में तो it's 12 protons, like, but in some other atom, the number of protons can be more and they can be less, right? So इसको nuclear charge या proton number, ठीक है, you can call that. Any other factor?
Number of electrons inside the atom.
चलो ठीक है, पहले दो पे हम कर लेते हैं बात, वो लिख लेते हैं. अच्छा, there are actually 5 factors. ठीक है, so we'll talk about the first two. The first two are the important ones. Number 1, that's nuclear charge or proton number, right? So the first one is simple: more nuclear charge, more protons. So if there's more protons, there's going to be more attraction between the nucleus and outer electron. So more energy would be needed. Or you can say that there's going to be higher ionization energy. Higher I dot E. I'm going to just add one thing. Remember, ionization energy, that's something that's endothermic. It's always required. The electron is not going to remove itself. You have to give it energy, so it's something that's endothermic. Its energy value is always going to be having a positive sign. Okay, so the electron always needs energy. It always needs energy so that it can go away. Achha, second क्या था distance or radius, right? Atomic radius or distance. So second factor is distance. So attraction is inversely proportional to distance. For a larger distance, between electron and the nucleus, अच्छा अगर तो larger distance होगा, then it would be easy to remove electrons. There's going to be less attraction. And you'll have a lower or smaller ionization energy. So अगर electron जो है ना बहुत दूर है, ठीक है, so it would be a lot easier to remove that. अच्छा, third factor is called shielding. ठीक है, it's called shielding effect. The shielding effect is the number of inner shells. And if I go over here and I, let's say I get rid of, let's say I get rid of, let's say I get rid of the inner shells. Okay, all the inner shells are gone. So what will happen is there's going to be a stronger attraction between this this electron and the nucleus. वो जो inner shell है ना, they kind of block the nuclear charge. And let's imagine you have two magnets, right? You put lots of things in between them. You have this electron and you have the nucleus over here. If you put lots of things in between them, the attraction would automatically be lesser. Because the nucleus, that's the one that's going to try and attract the electrons on the outside. ठीक है, तो ये जाके उसको pull कर रहा है. So you've got lots of things in between, then the attraction would obviously be lesser. ये clear है?
जी sir.
Or similarly, if you don't have inner shells, right? If all of this are gone, then the attraction between this outer electron and the nucleus is going to be a lot stronger. So that's known as shielding effect. Shielding effect is a fact. It's similar to distance. The closer the electron is to the nucleus, the less shielding there is. Because ये वाला जो electron है ना, there's nothing in the way. But if you look at this electron over here, this electron is directly attracted to the nucleus with nothing coming in the way. As the distance increases, the shielding usually also increases. You go slightly further away. If you look at this electron over here, then this electron has these electrons coming in the way. और दूर जाओगे तो there's going to be more shielding, right? This electron, a lot more electrons are coming in the way. So as you go further away, the shielding also increases. ठीक है, अगर iodine का case होगा ना, let's say if we look at an iodine atom, उसका अगर structure मिलता है, so I mean that atom has a very large amount of shielding. If you look at this electron on the outside, then it's lots of inner electrons are coming in the way. Okay? So there's a lot of shells coming in the way. So the nucleus will not be able to attract this outer electron. एक तो reason distance का है, ठीक है, but the other reason is lots of electrons are coming in the way. So that's another reason for that. अच्छा, तो ये shielding है, ठीक है. So remember, shielding and distance are kind of correlated. ठीक है, distance increases, shielding also mostly increases. As a shielding effect, what is the shielding effect? That it's as the number of initials increase, so as the number of initials increase, what you have is more shielding. And if you have more shielding, there's going to be lower ionization energy or smaller ionization energy. It's going to be easier to remove electrons. Okay, so there's going to be a lot smaller ionization energy. So, ये clear?
सर
हाँ जी.
सर असल में तो एटम का यानी वो तो सारे ऊपर नीचे हो रहे होते हैं ना, यानी सब के सब तो एक ही लाइन में तो नहीं होते. तो सर इस लिहाज से तो वो जो इलेक्ट्रॉन्स ऑब्स्टिकल बन रहे हैं वो तो नहीं बनेंगे.
नहीं, ऊपर नीचे थोड़ी होता है. हमने एटम की व्हाट.
नो सर, ये जो शेल्स होते हैं सर, वो जो असल में कॉम्प्लिकेटेड स्ट्रक्चर ऑफ एटम होता है.
नहीं, मैं तो असल में शक्ल तो ये है ना. एक सेकेंड. अच्छा, एक्चुअल शक्ल जो है एटम की वो तो ये है. तो वो जो इनर शेल के इलेक्ट्रॉन्स है वो उसको न्यूक्लियस को सराउंड कर रहे हैं. तो जो आउटर शेल का इलेक्ट्रॉन जो यहाँ पे घूम रहा है, राइट, जो एनर्जेटिक इलेक्ट्रॉन है, ये
जी सर.
तो ये इलेक्ट्रॉन जो एनर्जेटिक है उसका नेगेटिव चार्ज ये सारा फैला हुआ है, तो वो इट्स कम अट्रैक्ट होगा ना, क्योंकि वो बीच में इलेक्ट्रॉन इतने ज्यादा आ गए. क्लियर है?
जी सर. जी सर.
तो तुम उससे इमेजिन करो कि टू इलेक्ट्रॉन्स यहाँ पे ना, वो टू इलेक्ट्रॉन्स उनका नेगेटिव चार्ज पूरा सराउंड कर रहा है उसके न्यूक्लियस को. ये जो 1s2 नहीं है यहाँ पे, दैट्स तो
जी सर, ओके, समझ गया.
हाँ, तो वो जो ड्राइंग है वो तो सिंपलिस्टिक वर्जन है ना, उसमें तो इतना लगता है कि गैप्स है बीच में ना, राइट, बट देयर आर नो गैप्स. ठीक है, वो इलेक्ट्रॉन्स का जो नेगेटिव चार्ज है ना, वो तो पूरे न्यूक्लियस को इट्स कंप्लीटली सराउंडिंग इट. ठीक है, तो
ओके सर.
अच्छा, shielding effect. अच्छा, fourth one. The fourth one is the net positive charge on the ion. As a net or overall positive charge on ion. अच्छा, इसमें what happens in this is now this is the net positive charge. Okay, I've got two atoms, right? One of them is Cl. One of them is Cl with a charge of +1, and one of them has a charge of Cl with a net charge of +7. अच्छा, जितना ज़्यादा overall positive. Now remember, I'm not talking about the nuclear charge over here. I'm talking about the overall charge. Overall charge होता है ना, वो it's the electrons and the protons together. ठीक है? So if the overall charge is +7, ठीक है, on the whole atom, जिसका वो lithium था, if you look at lithium over there, ठीक है, so this +1 is not the charge on the nucleus. It's the charge on the nucleus plus the charge on the electrons. उसका total charge, that's +1, right? And this is +3. Now remember, it's going to be a lot more difficult to remove electrons from an atom or ion which has a charge of +2. क्यों? क्योंकि वो electron deficient है, it's got a net positive charge, so it will be very strongly attracting its electrons. जो neutral atom होगा, it's not got any charge overall, so that means it's compared to this one, it will be attracting the electrons lesser. अगर उसी पे चले जाए ना Cl के ऊपर, if you just go back, so +7 में से it's going to be a lot harder to remove electrons because an overall charge of +7 indicates that it's got a very strong attraction for electrons. +1 के पास इतनी strong attraction नहीं होगी. Zero, with no charge, even lesser attraction for electrons, right? So the overall charge is also a factor. The more the overall charge is, the more attraction there's going to be. ठीक है, ये बात clear है?
जी सर.
So greater net or overall positive charge on ion that indicates that electrons are even more strongly held together. And it also decreases the radius as well. Because of the stronger attraction. So radius of the ions that decreases because of the stronger attraction. So which is why the ionization energy increases. It becomes more difficult to remove electrons. And then there's a fifth factor which we're not going to discuss right now, because it usually doesn't really matter that much. And that fifth factor is subshells and orbitals. That one is subshell and orbital arrangement. So ये वाला factor जो है we'll keep that. It only applies, doesn't really matter, not that big a factor. ठीक है, we'll talk about this later. Usually only matters. Subshells and orbitals, they don't really matter in ionization energy. It doesn't really matter whether the electron is removed from an s orbital or whether it's being removed from a p orbital. That isn't really that big a factor. Only matters in a few instances, so we'll discuss that separately. So this one is not a major. So this one is not a major factor. So remember, you've got four main factors. One is so the factors are all about this thing. Okay, is it going to be harder to remove electrons, or is it going to be easier to remove electrons? So you're going to have mainly four factors. One is number of protons. You got more protons, more difficult to remove electrons. You got less protons, easier to remove electrons. How far is the electron? If the electron is very far away, then it's going to be easier. Otherwise, it's going to be very difficult. I mean, removing the electron very close to the nucleus, that's difficult. Then the number of inner shells. You got more inner shells, it's harder to remove electrons. And then the overall charge on the whole thing. If the overall charge is on the whole thing, on the whole ion, is very large, then even then it's going to be very hard to remove electrons. So एक के ऊपर आ जाते हैं. Let's start with magnesium से start कर लेते हैं. ठीक है, let's sketch the ionization energies of magnesium. तो इसको पिक कर लेते हैं. I'm going to sketch this. अच्छा, अब ये कि and I'm going to make a graph of this. A graph of its ionization energies कि वो ज़्यादा या कम है. Remember, all of them are endothermic. ठीक है, so it's going to have 12. So that's first, second, third, fourth, fifth, sixth, seventh, अच्छा फिर 8th, 9th, 10th, 11th and 12th. ठीक है, so this one has 12 ionization energies. So I'm trying to remove the first one. So this is my ionization energy number 1, first one. क्या होगा with the first one? Is it going to be, compared to the other ones, easy to remove this electron or difficult to remove this electron?
Easy.
ठीक है, so the first one is going to be the ionization energy axis है. The first one is going to be easy. So let's say it's over here. Easy to remove the first electron. So first electron is gone. Now the whole thing has a charge of what? +1, right? Okay, it's now turned into an ion. So the first electron is, I've removed it. I said now I'm going to focus on removing the second electron. This one. Easy or difficult?
Difficult.
Why?
The net charge on the ion has increased.
Okay, बाकी सारे factors constant है. The protons are the same. The distance is the same. The shielding is the same. The only factor is that it's got more positive charge on the. I mean, the whole thing has a greater positive charge. So just one factor, right? So slightly difficult to remove electrons, right? थोड़ा सा फर्क पड़ा. अच्छा, now it's got a charge of +2. ठीक है, the whole thing has a charge of +2 now. अच्छा, now I'm trying to remove the third electron. अब क्या होगा the third one?
Difficult.
ठीक है, लेकिन अब कितने factors होंगे if I remove the third electron?
Shielding effect per effect होगा net charge on the ion or a distance.
ठीक है, तो अब ज्यादा factors आ गए because now the third electron is going to be very difficult क्योंकि the third electron was closer to the nucleus, so that made it harder to remove it, and it was less shielded as well, right? So इसका मतलब है third ionization energy, there's going to be a jump. ठीक है, all of a sudden the third one has drastically increased. It has drastically become more difficult to remove the third electron. But ये clear है कि as I changed shells, the third one was actually closer to the nucleus and it was less shielded as well. ये clear है कि there's going to be a jump.
जी सर.
तो एकदम से ड्रास्टिक जंप आया. अच्छा, व्हाट अबाउट द फोर्थ वन? ठीक है भाई, फोर्थ वन. अब फोर्थ के अंदर मुझे बताओ कि इज इट गोइंग टू बी, वो थर्ड की तरह ही होगा ना फोर्थ वन, क्योंकि द डिस्टेंस इज द सेम, राइट? और ये चार्ज बढ़ता जा रहा है. 4 हो गए तो दैट्स गोइंग टू बी +4, राइट? अच्छा, सो इफ आई रिमूव द फोर्थ वन वुड बी काइंड ऑफ वेरी सिमिलर, बस हल्का सा ज्यादा होगा क्योंकि there's no factor. It's the same distance, the fourth electron, compared to the third one. It's the same exact distance, the same exact shielding, the same protons, right? The only thing is कि वो charge बढ़ता जा रहा है, ठीक है? And the same applies to the fifth. दोबारा जाके drastically कब बढ़ेगी? And the same applies to this is the fifth removed. I've removed the sixth one, the seventh one, the eighth one, the ninth one, फिर 10th one, फिर एकदम से 11th पे आके ना, when I try to remove the 11th electron, then it becomes all of a sudden very difficult because now you've gotten very close to the nucleus. तो 11th और 12th जो है ना वो मुश्किल होंगे, ठीक है? So if I continue the sketch, So the sketch would look like this. इस तरह के फिर अगली क्लास में बनाएंगे और अच्छा 11th and 12th was difficult. ठीक है, so the sketch would kind of look like this. Okay, the first two was easy. Then when you change the shell, then all of a sudden it became more difficult to remove electrons. So when you're removing the second shell electrons, it slightly became more difficult. And then when you started removing the first shell electrons, that became even more difficult. ठीक है, अच्छा within a shell इतना ज़्यादा फर्क नहीं पड़ता. Within a shell, the distance and shielding, everything is the same, except for every time you remove an electron, the overall positive charge keeps on increasing. So वो एक ही factor होता है. That's why the ionization energy gradually increases, but then there's a drastic increase over here. चलिए clear है?
Yes,
जी
sir.
अच्छा इस पे अब वो करना है कि एक वैसी प्रैक्टिस करना. मेक श्योर ट्राई डूइंग दिस वन. मुझे सेंड कर देना, व्हाट्सएप पे कर देना कि ड्रॉ द स्केच ऑफ एटम्स लाइक कार्बन. ठीक है, सिलिकॉन का कर लो, एक फ्लोरीन. ठीक है, ड्रॉ द स्केच. ये राइट दिस डाउन एज वेल, फर्स्ट सेकंड थर्ड फोर्थ. ये कौन सा एटम था? दिस वाज मैग्नीशियम. मैग्नीशियम विल हैव 12 ionization energies. Carbon will have 6 because it's got 6 electrons. Silicon will have 14. Fluorine will have 9. तो इन सारों का स्केच बनाना. ठीक है, एंड लाइक दिस. तो वो मुझे सेंड कर देना इन तीनों का. चलो ठीक है, कल बात करते हैं. ठीक है,
ओके सर.
ओके, अल्लाह हाफिज.